I am Dr. Mahammad Rafi, Associate Professor, Department of Cybersecurity at Institute of Aeronautical Engineering. Today, I want to discuss about the computer network subject, in which the topic is a network layer design issues. Here, outcome of the network layer design issues are efficient routing and data delivery can be done. That means optimal paths are chosen for the packet delivery, which is ensuring fast and reliable other communication. Optimal path finding, it is a issue. Here is this issue can be recovered. Efficiently routing the best path, selecting the best path, and effectively, reliably data can be delivered to the destination. Next outcome of the network layer design issues is scalability. Scalability, that means now networks can handle the growth with these issues now, handling the growth in the number of other devices. Once the issues are arise, the performance can be, by rectifying those other issues, so the performance can be improved. And the data traffics without the degradations that will be implemented. Scalable the networks. Next, the outcome is a effective congestion management. Here is the congestions can be, that means the prevented, and resolving the other solutions. That means the prevention and the resolution of the congestion networks can be done. And the next outcome of the network layer design issue is energy efficiency is the next outcome. Here is in a energy efficiency, reducing the power consumptions. That means in a network the device, especially for the IoT or wireless networks, any other wireless network, energy, the efficiencies can be, that means the power consumptions can be reduced in any wireless networks and IoT devices. Here, network layer the design issues. Generally, network layer in a computer system is responsible for routing. So, routing is nothing but a the path, finding the best path or finding the optimal path from source to destination for delivering the packet. So, this is the routing. And forwarding, it is responsible. Network layer is responsible for forwarding the data packets from source station to the destination station. And also the addressing that means forwarding means host to host. The communication can be done. Addressing, so it is a responsibility of the network layer, and which is ensuring that the data packets are delivered, data packets are traveling efficiently from source to other destination. Here is the task of the network layer is want to deliver the data packets. The task of the network layer is delivering the data packets from the source mission to the destination mission. While delivering these other packets, several issues must be addressed. So, by addressing those other issues and resolving the other solutions, effective other functioning, by effective other functioning, that will be resolved of the network layer by utilizing the network layer. So, the issues are, the first issue is a packet routing. That means now packet delivery. Packet routing means packet delivery from source mission to the destination mission. So, in between these, the source mission and the destination mission, number of routers will be arranged. Among these are the number of other routers. So, which finding the shortest path, that is a optimal path. So finding optimal path is a one issue. That means now the issue is determining the optimal path. Optimal path here, determining the optimal path. Determining optimal path is a one issue. Here is why we are going to determining the optimal path. What is the necessity means now fast delivering the packets from source mission to destination mission by determining the optimal path. Traveling from the source to other destination efficiently and reliably. That means the fastness can be improved. So this is the one issue. Now this issue can be resolved. For that one, the solution is implementing dynamic routing algorithm. By implementing the dynamic routing algorithm, so like OSPF, open shortest path first. So this is a one algorithm. So in this the algorithm, by utilizing this algorithm or and BGP, border gateway protocols or statistic routing for the smaller network. By using the different networks, by using the different other techniques over the network and different other protocols along with the different dynamic routing algorithms. Now, the shortest and effective path can be found. Here is by finding this the shortest path now, deliverable will be increasing the speed. Deliverable speed will be increased. And addressing. Next issue is a addressing in a network here while delivering the packets in a communication while using the network layer, while designing the network layer. Now addressing the issue will be arised. Addressing issue means here now device, number of other devices. The server is the communicating with the number of other devices here whom to send the delivery packet. Some issues will be arised. That means now address identification. Address identification is the issue. So this issue here, network layer design issue, this is one of the issue. That means now which is assigning the unique address to the particular identified device over the network. Once the unique address is identified, the data packets can be delivered to the particular the identified other device. Here is the unique address, the identification. How can resolve this the issue? Identification issue means now we are using the two protocols. We are using two protocols. That is a IPv4 is a one protocol or IPv6 is a another other protocol. Here is the IPv4. IPv4 now Internet as a protocol version 4 and IPv6 is a Internet protocol version 6. So by using this the two protocol, addressing can be effectively done. That addressing, finding the that identified as a device. Quickly finding the identified device, whatever the identified device is found with help of this IPv4 and IPv6 as a protocol. Now their data transmissions can be done. Here is now the techniques, one of the techniques is the DHCP technique. We are using the DHCP technique for other addressing, for addressing of the device. That means here DHCP technique means here it is a dynamic host configuration protocol technique. Dynamically, it will be configured the host, the identified device host randomly can be selected. With help of this technique now, randomly selecting the host, selecting the other device. Dynamically, once if it is selected and allocating the address. Dynamic address allocation can be done. Randomly allocating the address and based on that address and the identification, the information, the data can be transferred from source to the identified device. Generally, these are the transmission here. If client server, the communication can be done here. The servers in this case now, if the servers are one single server and the clients are utilized multiple other clients, we want to send the only the single client data, here is it can be resolved. That means IPv4, IPv6, the addressing, and DHCP as a technique. Now these issues, these the problems can be resolved in a. So generally these issues will be arise in a network layer designing. Here, by considering these are the issues now, network layer should be the designed. Why? Because now in a OSI, generally if you, this is a common layer in a OSI and TCP IP model. So by using this as the layer, these are the network layer, data or the transmissions can be done. That means here, so the data can be transmitted in the form of this the packet. While transmitting the data, these issues will be arised. And next issue means now congestion control. Generally, over the network, when the congestion will be arise, when the issue will be arise means network is, whenever the network is overheated, in this other case, the congestions will be arised. So the issue is now overloaded the network. Whenever it is overloaded, so overloaded means now heavy traffic. If you transfer the other data, that means now more than the capacity of the network of the path, more than the capacity of the network of the path here, the load will be the increase on a network of the path. Once the load is increased on a network of the path from source to the destination here, so generally the congestions will be arise. So which leads the dropping the packets and degrading the performance. That means now with this issue now, some of the packets, all the once this congestion will occur here, all the packets now which by the operating system, all the packets can't able to transfer, and also here the performance will be the degraded. The performance will be the degraded here. The solution of this one here now, which use the active queue management. So by using the active queue management as a technique, like a RED means random early detection. By using the RED technique now, these are the congestion controls, the congestions can be resolved. That is for that one now we are using the active or the queue management, the technique can be utilized. Here the applying the traffic shopping method, such as the token bucket or leaky buckets. Token bucket and leaky buckets can be used. And fragmentation and reassembling. Fragmentation and reassembling means now, generally the fragmentation will be arised more than the capacity of the network. If you are loaded more than the capacity of the network or less than the capacity of the network, generally two types of these are the fragmentations. If it is the data load is more than the network the capacity, so external fragmentation will be arised. Suppose the data load is less than the network the capacity, the internal fragmentations can be arised. And reassembling, fragmentation and reassembling. Here is the issue. What are the issue now? Generally we are facing means while designing the network layer, large packets must be fragmented to fit within the MTU of the network. Here is which is fitting the MTU of the network. Here the solution for this one is ensuring the proper fragmentation. Whatever the available size of this the MTU, based on this the available size of this the MTU, now the packets can be fragmented. That the packets number of it will be arranged. The packets will be arranged. Here is now which is discovering the packets, and depends upon that now reassembling at the destination. By reassembling here, same whatever the packets you are transferring from the source side, so it will be the again reassemble at the destination at the original size. Here is the Original size now we can get, suppose now from the source system, from the source system, this is the source device, source of the device. Now here the packet are transmitting to the particular the identified as the destination device, particular the identified the destination device. Here actually the packet original the packet the size is a 200. So this is the packet now we are going to the transferring. So the size of this the packet is a 200. 200 is the size of the packet, and the MTU size is the MTU size is, so it is a 1500 only. That's why now these whatever the packets now we are transferring 200, 2000 size, 2000 size here, whatever the packet now we are going to transferring the 2000 size. So network size actually the capacity is up to 1500 the size only the network can be carry the data. So in this other situation, in this case now this can be divided into the packet can be divided into two parts. So one is a the 1500 is a one packet, and another packet is a 500. Like this now, these are the packets can be transferred. Once if it is reaches to the destination device, that means the destination host, it will be received as a original size of the packet. That is the original size of the packet is a 2000. 2000 is a original size of the packet. So like this now, reassembling can be done. Wherever the fragmentations are arised, here actual the size of the frame, the size of the frame here it is the size of the frame is 1500 the capacity. Here the size of the frame is a 500 capacity. The suitable flexible the frames now the packets can be divided into the two parts. This it will be partitioned into two parts, and that will be arranged in a flexible data packets and transferring at the receiver side. Now it will be the reassembled and getting the original size, whatever the data, whatever the packet size we are transferring, avoiding the exclusive fragmentation, external fragmentations by that, and adjusting the packet size to the frame. The here is packet size will be adjusted to the equal to the frame size. Like this now, these the fragmentations and resembling the issues can be resolved by resembling the process. Next, internetworking. Here is internetworking. Generally, this is one of the issue. When this issue is generally is arise means now, whenever we are connecting the heterogeneous of the networks, whenever we are utilizing the heterogeneous of the networks now with the different other protocols or addressing the schemes now, so it will be utilized. It will be this issue will be generally arised, addressing different types of the addressing schemes or different types of the protocols now. With this now we are going to using here. So it will be the connecting to the heterogeneous of the networks. So this is the internetworking issue. Now for this internetworking issue now, we are using the routers for protocol translations. Now using the routers for the protocol translations. Generally here with the different protocols. Different other protocols now which will be transferred via the routers. And implementing the network address other translations. Over the routers, the data, the packets can be transferred. So without the disturbances now, the communications, whenever now we are going to implementing the network address of the translation, here based on this the network address, the data packets can be transferred to the particular network on the particular host. Whatever the hosts are working on that particular network or particular device, for that other device it will be transferred using the routers for protocol translations and implementing the network address other translations. That is implementing the, so it will be implementing the NAT. Quality of service. So what is the what is the quality of the services? Quality of service now issue is now providing the guaranteed the performance metrics. Quality of service means now correct data. So transferring the correct data. So it is a one issue. In a that means for example bandwidth latency for specific applications and a right time without other delay. So these are all the issues. And providing the guaranteed the performance matrices, guaranteed data, delivering guaranteed data, delivering the correct data. It is also one of the issue. For this one, the solution is a implement the quality of service mechanisms. The quality of the service mechanisms are differentiated the services. That is a DIFF SCRV, differentiated services based on the priority, and integrated the services, that is INT SCRV, for resource reservation. So different the mechanisms can be utilized for providing the quality of service over the other communications. Here, next the issue is a packet loss or error control. Packet loss means now packets may not be lost or corrupted during the data transmissions. This is one issue. So this issue general happen whenever the traffic, more the traffic is occur, whenever the data is overloaded. In this the case, our data is overlapped. In this case now, generally these packet loss or error control issue will be arised. For this, the solution is now error detection and correction methods can be utilized. Now, whatever the data you are going to transferring, and in this the data transferring, what type of the errors is occurred. So first we can detecting that errors and correcting that errors by using the some error detection and correction methodologies now, such as the error detection and correction methodologies are checksum and forward error correction, that is FEC, which allow the retransmission wherever necessary. That means whenever the errors are occurred, which is allowing, these are the technique now, FEC technique or checksum techniques now, which is allowing for detecting and correcting the errors, rectifying the errors once the errors are rectified, which is allowing for retransmission of the data from the source. Here is the, after some time delay now, how can you find the errors generally here now? Once if the source is sending the data from the device, that is some sender to the from sender to the receiver. If any the reaching is time is delayed, in this is the case now, generally errors will be, which is identified as a somewhat error that can be monitored over the network whenever it is necessary. Now, which can be handled in a higher layers. Now, generally it can be handled in a higher layers like a TCP, transmission control, the protocols. So it will be handled. Next issue, the security issue. It's a very important issue generally is arised while designing the network layer. Why? Because now many of the networks are, that is a vulnerable. So data packets are the vulnerable to attacks like spoofing or interruptions or tampering, hacking the data. That means now the solution for this one is implementing the IP security for encryption and authentication at the network layer. At the network layer now it will be implemented, and using the firewalls and intrusion detection system now, so it will be protected. Scalability. Scalability is another issue. In this the scalability, now the network must be handled. So growth in the device and data traffic without performance degradation. Here is the scalability issue. Whenever it is not, the networks are not scalable. Whenever how many devices we are going to using on particular network, if it is not scalable, automatically that network and the performance will be degraded. That means on one particular network now, or that means using the 100 other devices or 200 devices or 300 devices, it must be scalable. So the scalability is another is the most important issue. Why? Because based on this the scalability, data that is depends upon the growth of that network, growth of that device. Here the handling can be depends upon data handling can be depends upon the based on this the scalability. This is the one issue. If it is not properly identified, if it is not properly declared here, now generally this issue can be arranged here. The solution for this one is using the hierarchical routing. Here we can use the hierarchical routing to reduce the routing table size. By using the hierarchical routing now, routing table size can be reduced. By once if it is reduced here, the scalability is very easy. That means the size is the very small routing table size here. Effectively now finding the best route to the particular other destination. And implementing the IPv6 Internet Protocol version 6 for larger address spaces. Why? Because now this IPv6 now which is supporting for the 2 to the power of 128. 2 to the power of 128 bits. The size of this address space is 128 bits. Here this is the size of the address space of the IPv6. Why? Because now the IPv6 address can be represented in the form of the hexadecimal. It is an enhancement of the IPv4. IPv4 which is support only 32 bits only. 32 bits address space. But now IPv6 now which is supporting the 128 bit address space. So that's why it is a very better for resolving this scalability the issues. So for, whenever the network is a very large network or address space is a very large address spaces, now the using IPv6 now that can be resolved. So this is about the scalability and multicasting and broadcasting. So multicasting and broadcasting means now efficiently delivering the other packets to the multiple receivers. That the recipients means multiple other receivers now delivering packet. So that means efficient in time delivery to multiple resources. It is a issue. Multicasting means many devices to so many other devices, many to many communication. Broadcasting means now one device to the many devices that communication can be done. Here is one device to sending many devices. So it is also an issue while designing the. So all these issues will be considered while designing these are the network layer. So the efficient delivery of the packet. So we have to consider while designing the network layer and multiple recipients. That is a multiple recipient, multiple receivers. In broadcasting, multicasting. Multicasting is many senders and many receivers. Broadcasting means here one sender, one mission is sending, multiple missions are receiving this one. The solution for this one is using the multicast of the protocols. Here is for the multicasting. Now we are using the multicast of the protocols. The multicast of the protocols generally we are saying it as a IGMP. IGMP is which is support for the multicasting and the broadcasting. Both it will be supported. That means IGMP is a Internet Group Management Protocol. Over this Internet now, these are the protocols we are utilizing. And PAM protocol also used for the multicasting and the broadcasting. Both for the PAM, it is used for protocol independent multicast. So independent multicast, many devices to many devices. Now while establishing the communication from many devices to many devices, generally we are using the IGMP and PAM other protocols. Why? Because here if you want to transfer the data from devices between the two devices, if you want to establish the communication between the two devices, the protocols without other protocols now we can't transfer the data, we can't able to communicate the data. The protocol support is required here. By attaching this the protocol header and the protocol now, the data transparency can be done in a communication. Here is heterogeneous network integrations. Heterogeneous network integration, generally the issue what will happen means now the communication between networks. Here between the two different networks or between the two same categorical networks. So using the different other technologies and protocols. Here this is the issue. If you want to establish the communication between the two different networks, we have to use the different other technologies or different other protocols for establishing the other communication between the two different other networks. So for that now, we are using the gateway protocol. We can resolve this heterogeneous network the integration technique issue now with help of the gateway protocol. So these are the gateway the protocol for protocol conversations, which is a protocol conversation and ensures the capability using the tunneling methods. Ensures the capability using the tunneling methods. That is like a 624. 64. That is a 624 means now IPv6 version to IPv4 version. So which is joining these two versions IPv6 to IPv6 v4 other versions now. So it will be the joint tunneling can be done by tunneling now. By tunneling the process this heterogeneous network the integration issues can be resolved. Whatever the issues are arising in a heterogeneous network the integration, so that will be resolved. And energy efficiency. So in terms of energy efficiency, the next issue is energy efficiency. The issue is now high energy consumption in a device which impact the battery life. So here high energy consumption, if you consume the very high, so the battery which is impacting the battery life, for example is in a IoT devices, batteries will be the it will be affect the batteries. That means here for that one the solution is now, that means the batteries will be the damage if you consume the high energy in a batteries in a IoT devices. Okay, so it will be the leading to the damages. The batteries will be the damages. Solution for this one is optimizing the routing algorithms. Here is now optimizing the routing algorithms for energy efficiency and implementing the sleep modes for ideal nodes in a wireless the technologies. These are the solutions now which is ensures reliability, efficiency and the security in a network layer operations. Reliability means now correct data without the delay. The data can be transferred to the particular the destination. Providing more security is a very important while designing network layer. So these are the issues will be considered, which ensures once if you resolve all these issues now, the network, whatever the network now you are using, so whatever the devices are working under the network layer, it will be the ensuring the reliable the transformations and very efficiently and very effectively transferring the data and providing the more security. Whatever the data we are the transferring over the network now will provide the more security for the data. So this is about the network layer design issues now. So table now in terms of these the tables issues and solution. Packet routing now for this one we are using the different other protocols and algorithms. That is a dynamic static routing protocols. By using these protocols OS the PF, BGP and RIP protocols we can resolve. Addressing issue means now IPv4, IPv6 and DHCP protocols. So it will be the resolved. Congestion control, traffic shaping and token leakage or bucket leakage algorithm now the congestions will be the controlled. Fragmentation and resembling. So MTU discovery protocols can be used. Adjusting the packet size to suitable frames. Whatever the packet size is available for transferring. So that based on that now the frames will be allocated. Here is the internetworking. Internetworking means routers and NATs can be utilized to the issue of the internetworking. Any issues is arised, it will be used. And QoC, quality of service, that is a different other services or different INT service or DIFF services can be utilized. If any packet losses or error detections are arised, now we can use the methods or the checksum methods. Checksum methods are retransmission data retransmission, the checksums and FEC. These are the methods can be used. The security means now, once the security issues are arised while data transmission, we are using the IPsec, IP security, firewalls and IDS methods. By using these the methods now, that can be resolved. Scalability means, so we can hierarchical routing can be done and utilizing the IPv6. IPv6 and hierarchical at the routing now, the scalability issues can be resolved. And multicasting and broadcasting. Multicasting and broadcasting now, we are using IGMP protocol and PIM. By using this now, multicasting and broadcasting issues can be resolved. Heterogeneous network integration. That means gateways or tunneling can be done. So 6 to 4, that is IPv6 to IPv4, the tunneling and gateways by using this one now. Heterogeneous network integration issues can be resolved. Energy efficiency for that now. Optimized routing and sleep mode for the nodes. That is a battery now by using this optimized routing and sleep mode, introducing the sleep mode as a technique now. So battery life can be improving the battery life in especially in a IoT devices. Here is the textbooks for the network layer design issues or data communication and networking. That is the origin and computer the networks by S. the Tenenbaum. So this is about the network layer and other design issues. Now here, while in this summarization now, in this whenever communicating the devices, whenever here we are going to designing the network layer, we have to consider all these issues. By considering all these issues now, then we have to go for designing the network layer. If you design the network layer towards resolving all these issues now, the communication can be done very smoothly from the one device to the another device. This is about the network layer design issues. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.